Hello and welcome to today's overview of the basics of C Sharp. We're going to try to build a very simple ASP.NET web application. You can use this for a guide for Lab 6, and then I'll leave out some steps that you can complete on your own. So in this lab exercise, we're going to use some of the basics of C Sharp to explain what it is that we do anytime we attempt to build a website using ASP.NET. So a few things we need to know about C Sharp. C Sharp is case sensitive. We probably know that by now, right? Lowercase age for age is not the same as age with uppercase A, right? So uppercase, lowercase makes a huge difference in C Sharp. When we're writing code, the compiler is going to read top to bottom. So the sequence of the code is very critical, right? The first statement is going to be executed first, then the next statement, so on and so forth. So pay attention to the sequence of the code as we try to implement different functionality. And lastly, we need to be very precise when we write C# code, right? The computer is dumb. You're trying to provide some information, give the computer some instructions on how to perform a task, and so you're in control, right? Garbage in, garbage out. C# statements must end with a semicolon. So a statement is something much like this, right? When we write a sentence, as in C# code, an instruction, a complete instruction, we would want to terminate that with a semicolon. White space means nothing. So if I had a space between with and the asterisk, which is the multiplication sign, that white space means nothing in terms of executing the program. So code can span multiple lines. It won't really affect the code. However, you're advised to leave spaces where need be to make your code legible, so it's easy for somebody else to be able to read your code, and for you to be able to come back and read your code down the road. This slide talks to the anatomy of C# code. So let's go ahead and fire off a web page or a web app, and we'll be able to walk through it to describe some of these concepts in a little bit more detail. So I'm going to go to File, New Project in Visual Studio. Select ASP.NET Web Application. I'm going to call this Lab 6 just for an example. Click on OK. Turns out I already have a Lab 6, 6A maybe. All right, here we go. I'm going to select the empty project template. Select Web Forms. We've done this before. This is not new. Hit OK. That's going to create a web project in Visual Studio. The first screen that you see, this is for some guidance. You would never use this in this class, but you could use the tutorials as a guide if you want to learn more about ASP.NET. For the sake of what we need to do, you will always want to close out of this window, right? So close out of this. Make sure your Solution Explorer is showing and it's pinned. In this case, I'm going to pin mine. I'm going to pin my Properties window because we're going to use this to build the app. I'm also going to pin my toolbox to make life a little bit easier. Again, if you can't find these three windows, you can find them under the View menu. Make sure you have them selected. You should be good to go. All right, so I want to create a new web form. I've got a basic structure of a web page in here. To add a new form or HTML page, I'm going to right-click on the project, select Add, Web Form, right? Add Web Form would allow me to create a new web form. And we know the default.aspx page is typically your default page. So I'm going to type in the keyword default for the name of the page that I'm looking to create. That creates a page. You can see the Solution Explorer default.aspx, right? Now I'm going to switch to the design view because this is the source is going to show me some HTML code. Since I can't guarantee that we all know how to write HTML code, we're going to be using drag and drop functionality in this class, right? And then HTML, CSS, JavaScript code will get created behind the scenes for us where necessary. So we're going to switch to design view. If I need to add some text pretty quickly to this. I could find the right controls, but keep in mind every control that we use in this class should come from the standard category. Ideally, you want to design this using an HTML table, or if you know how to write CSS, that would be the ideal way to do things. In the interest of time, I'm going to find a quick and dirty way to implement a nice UI that would get some of the concepts that we're interested in discussing in this tutorial through fairly quickly. So I'm going to build some functionality that would ask a user for their first name, and it would also ask them for their last name, and it might perhaps ask them for the age, and perhaps there'll be a button that they click on. And the goal of this program is to show the results right down below, right? So I'm just creating some placeholders. So the first thing I'm going to do is add a text box. So I want a user to be able to input something. So I'm looking for a text box. Remember, do not find anything, do not select any options under the HTML category. In fact, let me close that out, collapse that. We're looking for text box under the standard category, right? So I'm going to drop that in here, hit enter on the keyboard to move that down. I'm going to hit enter on the keyboard again, move that down, just create some spacing. These are all user input fields. The user is going to type in their first name, their last name, their age, and I want to show some results, but I want to take an action, a user to take an action by clicking on a button, right? And once they click the button, I'm going to show some results. So I'm going to use a label control to show the output, right? Label controls are useful for showing read-only content. All right, so I think I have what I need. The next step in design typically is to change or set the ID property of all your controls. Okay, so I'm going to go ahead. We learned previously what the prefixes need to be. I'm going to use txt first name, right, as the name of my text box for first name. Then I'm going to set this to txt last name. Then I'm going to set this to txt age, something like that. Well, this button also has a property that I'd like to set. I want to set the ID to btn show results. Right, so when you click on the button, I expect it to show some results. Then I'm going to change the default value that shows on this button to show results. Right, so that I'm setting the text property of the button. For the label control, I could set the value to LBL results and perhaps remove the default text. You can remove the default text. When I remove the default text, you would notice the name of the label shows up by default, right? So maybe I'll go ahead and change the color. I'm going to change the full color to something else, maybe something like that. Let me go ahead and set some default value. Results show here, ... something like that. All right. I could highlight and hit Command B on the Mac, Control B. Anywhere in Windows usually means bold, so I just want to make these bold. You can make this look as nice as you need to, right? So that's my basic UI. I've given each one of these controls an ID. Now remember what we talked about event handlers. So key event handlers, I'm clicking Command S or Control S to save my form. Key event handlers in this case could be when the page loads, maybe I want to take some action, right? So in this case, when the page loads, I might be interested in setting this value to no results set, for example, right? So I need to create an event handler such that I can set some code, write some code to change the value of this label control. Then I might also want to write some code to print some results once this button is clicked on, right? So let's test this app before we get too far. So I'm going to launch this in the web browser. Hopefully this goes pretty quickly. Sometimes Visual Studio can be slow in compiling. But essentially the goal is to be able to see the initial value, which is, I've got my nice values showing here, results shows here. This is what I was looking for, and it works as desired, right? So I'm going to close out of this guy, stop running. The next thing I want to do now is write some code in the page load event handler, right? So it would change this to no result set. And that's going to teach us a couple of things. The fact that controls have properties, and how can we get and set the value of this label control. So if you double click any of the white space on this page, right, this white space here, it would create a new file, and in that file you would see a method called pageLoad. PageLoad is an event handler, and it has a couple of arguments, right? But more importantly, an event handler is a method. Now methods belong to classes, and a class, let me add some notes in here for your reference. A class can have multiple methods, right? So now that I've got what I need, maybe I could minimize the toolbox here. So what did I do? I double-click the white area here to create a page load event handler, a method that allows me to write some C# code. So most of our code, not all of them, most of the code that we write in C# for web apps would go in some method. A method is a named block of code, right? So take some notes on that. Method is a named block of code. So I want to write some code that assigns a value, a string value, to the label control. So to do that, I start typing in LBL, right, results. That's the name of the label control on the screen, right? So LBL results. But the value that shows in the label control is, let me select this guy, is in the text property. Notice this text property, that's where we're showing results show here. So when I write C# code, if I want to change that text property, I have to use this dot notation. The name of the control dot the property. Control.property, control.property, right? So now I'm saying assign equal to in C# means the assign operator. So I want to assign some value to this, the property, the text property of this control, right? And I want this to say no result set, right? Something much like this. So this is going to, this code, piece of code is going to run when the page loads, and it would assign this text value to this control, and specifically the text property. We would never write code against the label control or a control directly. We would always, in this class, write code against a property of a control. And as we go through the class, it'll make a lot more sense. But just try to keep that in mind. Anytime we're assigning a value to a control, we want to assign this textual value to this guy. We would need to use the equal to sign. We need to terminate the sentence or the statement with a semicolon. And the reason why I put the double quotes around this is because this is some textual string value, right? And if I hover over the text property, this is a string data type. So we have to make sure the left-hand side of this statement has the same data type as the right-hand side, or at least they're agreeable. So this is some string. I'm assigning a string to another string. The control has a property which is a string. It takes a string type, right? So that text is always a string type. So you can always assign a string value to it. You cannot assign a numerical value directly to a string value. And we'll do more and more of that next week, right? So this is going to assign this value to this controls property when the page loads, when that action happens. Let me show you one thing you could do in Visual Studio. You could split your screen, because if this is becoming confusing, right, you want to be able to see the UI and your C# code. You could simply right click on one of these new vertical tab, and I can split my screen so you can see the UI, the user interface, at the same time as you're writing your C# code. Sometimes that's useful for some, perhaps it might not be useful for others, right? So that's just one of the nice to haves. One other keynote. Web pages or ASP.NET pages have what's called a code behind. So this page load is a code behind default.aspx.cs. You notice this is default.aspx. This is default.aspx.cs. This CS is short for C#, right? That's the code behind for this web page. This is the code that runs on the server side. This might be what gets displayed on the client side, right? With the HTML, the CSS, all that good stuff. But this code is going to run on the server that's going to be hosting this web page. Right, so that's the distinction that you probably learned in software engineering. Anytime let me close out of this window, we build code in C#, we might have a namespace. A namespace can have multiple classes in it. A namespace is just the name of the application, but we can have multiple namespaces. We'll learn about that later on. We call these using blocks. These using blocks simply allow us to bring in code from different sources. So if Microsoft is built some plumbing for how to multiply two numbers or add two numbers together, that might be in what's called an assembly or a dynamic link library, DLL, right? And the references to those DLLs come in through the using statements. Those would typically be at the top of your C# class, right? And so we're going to write some code by inheriting some code that somebody else has written. Anything that starts with system, using system, means it was developed by Microsoft. So this is code that was written by Microsoft. Since we're using a Microsoft system, you start all the namespaces with system. So this is using somebody's namespace, system, Microsoft. Now I can use some functionality that they built in my application. Right? Don't worry too much about that. So let's go ahead and test this. I'm going to save this and see if it shows the results that we're looking for. So we click on that. And now it shows no result set. Notice as soon as this page loaded, the text that I had previously was replaced by no result set, right? But if I click this button, it actually does nothing at this point. The next thing we're going to do is figure out a way to take the input from what the user is going to type in here and the input that is typed in here, concatenate that, put it together, and then display it in this label, right? So we'll figure out how to do that. All right, so we'll go back to our C# code. Actually, let's go back to the ASP.NET page, switch back to design view, and now I want to create an event handler for this button. To do that, you need to double click on the button, right? Double click, not single click. So I'm going to double click show results, and a method gets created for me, right? So I've got an event handler, which is a method. It takes the shape of the name of the control, which was btn show results underscore click. It tells me this is the click event. And now I can write a block of code in here, right? So let's start by showing something on the screen once you click this button. I want to change the results to some results set by user, right? I want to change this. When the page loads, I'm going to set this property to no result set, And when you click on the button, I want to show results set by user, right? A little goofy, but it illustrates the fact that we can write code in different methods, different event handlers. And so let's go ahead and test it out. I'm going to save this again. And as you write code, you want to test your code after every few lines that you write, right? Because that way, if you make a mistake, it's easier to catch it. If you write 50 lines of code and then you go back to test it, it might take you a long time to debug it if you have any errors. Anyway, so now we load the page. It shows no result set, which is different from the default that was set in the property window, which is results show here, right? So this is the page load event fired and displayed this. Now if I click show results, notice this changes to some results set by user, right? So this is working as desired. We've got some nice functionality going. Next step, let's try to figure out how we can take an input that was typed in by the user and build a sentence in the results section. Okay, I'm going to click out of this. I don't need to make any changes to the design. This is all C# code now. So the first thing I want to do, let me minimize Solution Explorer and get that out of the way so you can see what I'm doing here. I can minimize output because we're not really using it at this point. All right, so now I need to take some input from a user, right, and plug it into a sentence. It might make sense to have some understanding of the concept that is known as variables. So we know all about comments, how to add comments. You can have comments span multiple lines using this approach, right? IntelliSense, error messages, we covered that in the previous lab. Here's an example of having comments that span multiple lines. You can play with that. Let's talk about variables. Variables are containers that hold data in RAM or memory. That's why we were learning all about memory, right? So when we're trying to make calculations or work with data, sometimes it makes sense to put it in a bucket, right? And then massage the data potentially, do something with the data, some type of calculation, get a result, and then show it on the screen. So we might have some type of process. When we're doing something like that, it makes the most sense to create a variable, right? A variable would be just a part of memory that has a name, a container. But variables have what's called data types. So a variable would have a data type. It might be an integer, a string, a Boolean value, a date time value, so on and so forth. Constants are just like variables, except they remain constant. The name constant means it doesn't change, whereas variable means it varies, right? It's a derivative of the word vary. So it's likely to change, whereas a constant is another bucket that would hold some data, but it would never change for the life of the application, right? So that's the difference between the two. Here are some examples of data types that we would need to create variables. So integers, float. Integers are whole numbers, right? So a whole number that has no floating point fractional aspects to it, right? No fractions, integer. Int for short. Float, double, and decimal would all be numerical values that have some floating point aspects to them, right? So something dot something, like currency, right? 899, the list price is 899, something like that. Decimal values have a higher precision, meaning I can have multiple decimal places if I need data to be really, really accurate in a financial calculation. I more than likely would be using a decimal data type. For the sake of this class, in most of the cases, we're going to use double and maybe round to at least 2 decimal places, right? So double is a good choice for most of our calculations. Boolean means we have to save something that's more true or false or yes or no type value. String would be any textual value, right? Not a number. Textual value. Date time. There are a lot more data types, but these are some examples that we would use. If you need to really zoom into this, you need to know 3 specific data types to start. Int, double, and string. These are the three that we would use very frequently. More than likely we'll be using datetime as well. Okay. Sometimes you might need to convert a string to an integer to use it. And when you need to do that, you would use a method called int.parse. And you provide the string value. Here's an example. Right? If you need to convert from an integer value down to a string, there is this other method called the toString method. And here's an example. We can have a numerical value, we want to convert it to a string. We'll talk more about why would you do that next week. Here's an example of how you would create a variable, or the syntax for creating a variable, right? Variables can be initialized at the time they are created. Declared means when you create it, right? And you would have an equal to sign when you're initializing a variable. So if I want to create a variable, I could do something like int my value, right? And semicolon at the end, that means I'm creating one variable. I can create multiple variables on the same line by using int my value, other value, your value, so on and so forth, and then I'll terminate that with a semicolon. That means I'm trying to create multiple variables on the same line. Var is an implicit way to create a variable without declaring the data type. So when you create a variable, it should be in this format: the data type, which is int, float, decimal, something like that, and then some variable name that you make up, right? It's just a bucket, a container, so you name that container, right? So we need to know what type of data is going to be stored in the container. But if you use the var keyword, then you must provide an initial value. So notice var is short for variable. Var my value equals 0. That means I'm assigning 0 to my value, which means 0 is potentially an integer value, right? In the same vein, int quantity equals 10. I'm declaring a variable called quantity. I'm assigning the initial value as 10. Or I could be creating a double data type called price. Initial data value is $8.99. The only way C# knows implicitly that this is potentially a double is because the initial value looks like a double data type, right? So C# is going to look at the initial value to infer what data type this is if I type in var, right? And here are some good examples. But let's go back into our code and create a variable to hold whatever the user is going to type in. So I'm going to create a variable. Because I know .text is a string, I'm going to create a string called first name. And I would set the initial value of first name to txt first name dot text. The goal here is to get the value that the user typed into the first name text box and assign it to some container that I'm making up. It happens to be a name that's pretty close to this, just because I want this to be descriptive, but I'm creating a variable which has an initial value of whatever the user typed in, so it's dynamic. And then I'm going to create another variable, string last name, and have it hold the last name value that the user might have typed in. So this is now dynamic. And then I'm going to change this code to say something like you entered and then I'll do something like that. First name plus as your name, right? So I'm trying to build a sentence of some sort. This plus allows me to concatenate, right? So plus, when you use the plus symbol while working with strings, it would put two strings together, right? Concatenation. So I'm not trying to add numbers together. I'm trying to add strings together. And when you add strings together, we'll call that concatenating. So you entered, we'll figure out the dynamic value that the user entered in, right? And we'll add it to this, create a dynamic sentence and display it in the label results control. So let me run this and see if this works, right? So when the page first loads, we still want to see no result set. And if I were to type in test, maybe let's go with John. I'll type in Doe, age, let's say 76. I expect to see you entered John as your name, right? Where John is dynamic. I took the user input and plugged it into a sentence. Now notice I'm not showing Doe yet. So for your lab exercise, you're going to want to figure out a way to show both the last name and the age in a sentence. Perhaps the goal would be you entered in your first name as blah, blah, blah. You entered in your last name as blah, blah, blah. The age is blah, 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 right? It could be a confirmation message before you submit the information. But the basic idea is that we can create variables to hold this and then build some type of calculation. In this case, we're only working with putting strings together. Next week, we'll look at how do we convert a number as an age value to something else. Maybe multiply quantity by price to get total cost or something like that, right? So this is all that we needed to cover. Read the lab exercise to complete the remaining steps, but I think you have enough information to finish the lab. All right, have a good weekend. Talk to you later. Bye-bye.